Hi everybody, I am Hiba Izzat. In this video I am going to show you how can we calculate different probabilities for the contingency table. The table in front of us contains the results of a survey or a study. This study was trying to connect the smoking behavior with the race. So, for male aged between 18 and 24 years. So, we have here two columns, each one representing the smoking behavior. So, here it's a smoker, the male is a smoker or non smoker, and for the rows, we have the probability he is white. So, this to would consider the number of the observations inside the sample referring to white and black or referring to the race of these observations. So for the contingency table we have the columns intersecting the rows. We call this intersection a cell. Each cell contains the joint probability of the two variables. So for example, the 290 represent the joint probability that the selected observation is white and smoker. Also in the contingency table we have to consider the totals, the column total and the row total, because if we want to calculate what's called the marginal probability, we would consider these totals, and of course we have the grand total that represents the total value of or the total number of the observations included inside the sample. So let's start. If we want to calculate the joint probability, and here by joint probability we have the table looks like this. Okay, I have here smokers and non-smoker and white and black. So the here it will represent, or the value that would be calculated here, it represents that the probability he is white and smoker, or I prefer write it he's a smoker and white. You would know later why, because this would be easier while calculating the conditional probabilities. And here the probability he is not a smoker and white, and this equals the probability he's a smoker and black, and the probability he's non-smoker and black. So to calculate these probabilities, okay, all what we have to do is to divide the values by the grand total. So we have here 290 divided by 1000, and we have here 560 divided by 1000, 30 divided by 1000, and 120 divided by 1000. Okay, so again we have here smoker, non-smoker, and white and black. So here it's easy to calculate because it's just divided by 1000. So we have here point 29, and here the probability is 0.56. Here it's 0.03, and here it's 0.12. To calculate the marginal probabilities, we again would divide the total, the row of the row total by the grand total. So it's 850 divided by 1000 and 150 divided by 1000. So in this case it would equal 0.85, and here it's 0.15. For to calculate also the marginal probability for the column totals, we also divide again by the grand total. So we find here the the marginal probability for the smokers is 0.32, and here it's 0.68. If we add this probability, these two marginal probabilities, we'll find it will equal to 1. And also if we add these two marginal probabilities, we'll find that it's equal to 1. So this is how can we calculate these relative probabilities and the marginal probabilities. So if we want to calculate the conditional probability, okay, so here we want to calculate the conditional probability. Okay, so here we want to know the probability. What's the probability that if we select an observation at random, what's the probability that he is a smoker given he is white? So to apply the rule, the probability that he is a smoker given he is white would equal to the probability that he is a smoker and white divided by the probability that he is white. So here we find that the probability that he is white is just the total of the row for the white white observation. So here the probability is 0.85, okay, or I can say it's 850 divided by 1000. Okay, the intersection between the two probabilities that he is smoker and white is just here, it's the joint probability he is a smoker and white. So it's 290 divided by 1000. Okay, so this would equal to 290 divided by 1000, and because the denominator of the denominator can be reversed, so we have here this of course will go with this. So the conditional probability would equal to 29 divided by 85, and this would equal to 0.34. Okay, so to interpret this result, we have 34% chance that the selected observation is a smoker given he is white. Okay, so this is to calculate the probability that this is the selected one is a smoker given he is white. So what is the probability that he is a smoker and given that he's black? So again, we can apply this rule. The probability that he's a smoker given he is black will divide by the probability of being black, here the intersection of smoker and black. In this case, we have the probability of black, of course, again it's the row total of the black observations. So here we find it's 150 divided by 1000, and the intersection he is a smoker given he's black is simply this one. And he is black, it's 30 divided by 1000. So here I can just this will go with this, so it's 30 divided by 150, or equal 1 divided by 5, or 0.2. So again, to interpret the result, there is a 20% chance that the selected smoker is black. So we can notice that the probability of smokers given he is white is higher than the probability that if he's a smoker given he is black. Okay, so this is to calculate the probability of some of the event given the other. Okay, so here if we want to check is race and smoking behavior are independent, okay, we can do this by checking if the probability of smoking or a smoker given he is white equals the probability he is a smoker. So here the race doesn't change anything or doesn't add any information. So if the equality is the case, in this case I would say that the two smoking and white are independent. So to check this, we will consider that the probability he is smoker given he is white is 0.34, and the probability that the selected male would be a smoker, here it's 0.32. Of course both of them are not equal, so we can't say that the two events or are which are the race and the smoking behavior are not independent, or they are dependent. Okay, and of course we can check this also in the case of P of S given the smoker given he is black. If this equality applies. In this case, it's dependent, but of course this is only for rechecking, but this result would be sufficient. So here the probability, it's a smoker, and given he is black, is 0.20, and the probability that the selected man is a smoker, as we can see here, it's 0.32. Of course both of them doesn't equal to each other, so as we found here, they are not independent, so smoking behavior may depend on race. Thank you for watching the video.